is my great pleasure to welcome Dr. Matthew Phillips to make a presentation today. Matthew doesn't know this, but the first time I met him was in 2020 when he presented a seminar to the Insights Conference, which is hosted out of Melbourne. And I had just been diagnosed in October of the previous year, and it was right at the beginning of lockdown, and I was sitting in lockdown thinking, what does life look like for me with Parkinson's? And I was really inspired by Matthew's presentation because it dealt with diet, and I have become convinced that my Parkinson's started in my gut some years before I was diagnosed. So I've always found this conversation around diet and having people like Matthew really spending time unpacking this for us is just so helpful to us as Parkinsonians. So Matthew, welcome to this webinar. We're delighted that you could spend this time with us, and over to you.
Thanks, Andrew. That was a very kind introduction. I'll just share my screen here. And hopefully everybody can see that okay. So my name's Matt. I'm a neurologist at Waikato Hospital in New Zealand. And today I'm going to give a talk called Metabolic Therapies in Parkinson's. It's similar to one I gave a couple of months ago because it just encapsulates everything I guess I'm thinking about Parkinson's at this moment in time. So I thought I would give a slight variation of it again. So in New Zealand, we're seeing quite a lot more Parkinson's in the last 20 years or so. It's actually existed for several thousand years that we know of, but it's becoming much more common. So if you look at these numbers, this is New Zealand data, just from 2006 to almost now, you've had about a 50% or more increase in the prevalence of Parkinson's, and that's, yes, many disorders are getting more common, but this is a tremendous rise in a very short period of time for a disorder that's been around for, thousands of years. So why is that? I guess a lot of people wonder about genetic causes of Parkinson's, and certainly some people with Parkinson's have a genetic cause. Perhaps 5 to 10% result from a single gene mutation. So the genes are the little codes in our DNA that make proteins, and the proteins do stuff within the body. So basically, a normal gene will make a normal protein, and a gene that has a mutation will make an abnormal protein or no protein at all. There are other options, but those are some of the major ones. And basically, in Parkinson's, some people, particularly if they get the Parkinson's at a very young age, 30s, 40s, they will get that from one of these reasonably well-known mutations. And they can be autosomal dominant or autosomal recessive. Dominant just means it doesn't skip a generation. Recessive means it skips a generation. So that is the cause of some Parkinson's, we know, but the vast majority of it, 90 to 95%, we call sporadic Parkinson's, and these are not the cause. So what causes the sporadic? Well, we have some environmental risk factors that we know are correlated with Parkinson's that may be involved in causing it. So two risk factors probably stand out more than the others. The first one is pesticides and herbicides, and I'm lumping those together. So people who are exposed to those chemicals have a 60% greater likelihood of developing Parkinson's. That doesn't necessarily mean it's the chemicals that cause that. However, it is suggestive. And what is also suggestive is that really these pesticides and herbicides have only become really widespread in the last 80 years or so. And of course, we've seen that rapid increase in Parkinson's prevalence in the last 20 years or so. So perhaps this is part of the cause of that. Second thing is head trauma. So people who get head trauma with concussion are 50% more likely to develop Parkinson's or Parkinsonism. And that could be partly responsible for the rapid rise we're seeing. I guess the thing about this one is boxing gloves have only been around in the last century or so. Before that, people would do bare knuckle boxing, and that was hard on the hands, but much easier on the brain. So since boxing gloves came out, we are able to protect our hands with this sport. And the brain takes a lot more hits, unfortunately, in the process, because you can just hit the head so many more times now before the knuckles actually break or suffer any damage. So maybe that's partly responsible for the recent rise in Parkinson's. But I guess these two things probably don't explain the majority of the rise, in my opinion. Possibly the greatest risk factors, and I can't really think of anything else that has changed as much as these two in the last 50 years. And it's very difficult to study them because basically almost everyone shares these two risk factors. Is the first, the fact that we eat so many times throughout the day. We eat a lot of times throughout the day. And although this seems rather harmless, and it's often recommended by many diet experts, it's very abnormal if you look at how people used to eat throughout 2 to 3 million years of evolution. So for a much, much, much longer time than the last 50 years. On average, people eat about 5 to 6 meals a day, and that's just, that is a lot of time throughout the day that one is eating. And the second risk factor that almost everyone shares is diets high in processed carbohydrates. Now, the word process means different things, but process means it's not in its natural state, the food, so it's been tampered with by humans. And most people eat a diet of about 35% fat, 15% protein, 50% carbs. So it's a lot more carbs than we're probably used to eating in evolution, most of us, and it's a lot more processing. And processing can vary. Something highly processed would be chocolate bars and sodas. But something that's semi-processed would be something like maybe buns, like on that hamburger there. So it has a wide variation in how you define it. But basically, I would like to suggest that our modern diet is really quite an abomination if you look at our evolutionary history. And so the idea of having 3 meals has only been around a few hundred years, really. And the idea of having 3 meals plus a bunch of snacks has only been around maybe 50 years or so. And the idea of having, many more carbohydrates in the diet, a lot of them processed, that's again another sort of thing in the last 50 years or so that's really come into its own. And these are just massive changes in our dietary patterns. I can't think of anything that's changed as much in the last 50 years. Not exercise, not sleep. All these things are not ideal because of modern society. However, they have not changed as much as the modern dietary lifestyle has. So perhaps that is driving this rapid rise in Parkinson's, and that's the angle that I take. So in order to understand this at an even deeper level, I think I just want to explain what is Parkinson's quickly. So a lot of people see this as a focal neurodegenerative disorder involving the substantia nigra, that little red bit in the brainstem there that the circle is around. And you develop these things called Lewy bodies within the neurons, which that's just a cartoon illustration of one. They don't, kind of look like that, but they're in the cells there. And you get this buildup of Lewy bodies, the substantia nigra, and a lot of people think that that is the problem, and that you get these major motor symptoms largely from that process in that region. And the classic 4 are tremor, rigidity, bradykinesia, and postural instability. The tremor and the rigidity is stiffness, usually affects one side for a few years before it goes to the other. And bradykinesia is, it can mean slowness, but it often means that when people are asked to do things that require repeated motions, that the amplitude of it gets smaller. So when your neurologist asks you to open your fist and tap your hand and stuff, they are seeing if the movements get smaller as you do that. And postural instability means you have a little bit of problems walking. So those things absolutely happen in Parkinson's. Those are the motor symptoms, but there's so much more to this disorder that's not covered by that, and it's not covered by the substantia nigra. So the non-motor symptoms are much more diverse and less easily recognized, even by the person with Parkinson's themselves, because you may not think that they're part of the Parkinson's. So gut dysfunction is one, constipation and bloating. Constipation is just as common as the tremor, if not more so. The sleep disturbance, so insomnia, can't get to sleep or can't stay asleep, and other sleep disorders such as a REM sleep disorder where you sort of talk, punch, kick in your sleep throughout the night. These are extremely common, probably more common than the tremor. Mood problems such as depression and or anxiety, these are extremely common. Pain syndrome, so people can get a frozen shoulder or sciatica or different other kinds of pain, and these are part of the Parkinson's actually. In most cases, autonomic dysfunction. So you can get dizziness when you stand up because of postural hypotension. So the blood pressure falls when one stands. Urinary dysfunction, resulting in a person having to go to the bathroom throughout the night, for example, excessive sweating. And cognitive problems do creep up later on. So apathy, loss of motivation, hallucinations where you see or hear things that aren't there, and cognitive impairment, so difficulties with memories and thinking and so on. These cognitive problems tend to occur later. So what is important to get from this slide is that basically these non-motor symptoms impair the quality of life. We know this more than the motor symptoms. In fact, just the mood problems alone impair the quality of life more than the motor symptoms. So it's really important that we recognize that there's a lot more to Parkinson's, and perhaps we should be focusing on more on non-motor symptoms than motor symptoms. In our clinics, we always try to work on the non-motor symptoms just as much, if not more. So why do those non-motor symptoms occur? So the reason is that Parkinson's affects a lot more than just the substantia nigra. So if you look at autopsies, it seems to involve neurons in the enteric or olfactory regions. So enteric gut, olfactory nasal passages. So the neurons there seem to die first, and then you get this sort of ascending process that hits the lower brainstem next, perhaps through the vagus nerve. And when it gets to the lower brainstem, that's where the sleep centers are and centers for other vital functions. So that's perhaps why sleep gets affected so early. And then the upper brainstem gets hit, and that is when a person is typically diagnosed because the motor symptoms start appearing. And lastly, the neocortex, that's where the cognition gets it because the neocortex is responsible for a lot of the thinking and cognition. So you can see this very clear process on autopsy studies. And so it's a spreading process throughout the body, and I mean the body, not just the brain. Now, before dying, these neurons show defective metabolism. So that metabolism means the chemical reactions inside the neurons. Basically means they're not functioning properly. Okay, so remember, genetics is kind of like the blueprint for the cell, and the genes make the proteins, and the proteins do stuff. So the proteins are part of this metabolism, and they're not working well. So what is the reason for that? Well, if you look at Parkinson's and other disorders that are related, such as Alzheimer's, there's widespread mitochondrial dysfunction. Mitochondria are the coordinators of cell metabolism. There are hundreds of thousands in almost all cells. They run around the cells and do stuff. And when I say do stuff, they basically are coordinating much, if not most, of how the cell expresses its genes, which proteins are made, which ones are not made. And all the reactions throughout the cell are probably being coordinated by these little guys. And they also produce nearly all the energy for the cell. So if you basically don't take care of the mitochondria, the cells will not work properly on many levels. And they're sort of, we often emphasize cell biology in medical school and in undergraduate courses in science and biology, both of which I've done. And we often, we sort of talk, at least I was taught a little bit about mitochondria, but really not anywhere near what I view their importance as being today. So in Parkinson's, the neuron mitochondria, it doesn't matter if the neurons are in, what part of the brain they're in, they are damaged and they're not functioning properly. So there's too few of them. They have funny shapes and sizes. They should be ellipsoid, and a lot of them are too small, too big, too circular, in some cases long and skinny. They don't fuse or divide properly. They're supposed to come together and split apart regularly throughout their life cycle. And They don't seem to do this properly. That's impaired population dynamics, essentially. They don't move around the neuron well. These mitochondria actually, there's little tracks inside the neurons, and they move all throughout the neuron, getting the energy where it needs to go. And they seem to be impaired in this process in Parkinson's. And lastly, they don't, of course, do not make enough energy for the neurons. This is a problem because neurons are probably, over time, the highest energy demanding cells in the entire body. So like the brain weighs something like 2 to 3% of the body weight, but it consumes 20 to 25% of the energy. So this is a problem. If the mitochondria aren't working, this is a major problem for neurons. I don't see how they can function properly. We know the mitochondria are working in Parkinson's, and we know the neurons are degenerated and dying off in Parkinson's, and not just in the substantia nigra, but in a lot of places. So to me, this kind of makes sense. Now, what causes the mitochondria dysfunction? Well, all those things I mentioned at the start produce mitochondrial dysfunction. The particular gene mutations in Parkinson's are known to affect the mitochondria on several levels. Pesticides and herbicides are known to damage mitochondria. Head trauma is known to damage mitochondria. The physical hits of getting knocked produces this thing called a neurometabolic cascade inside the brain. So physical hits can actually damage the mitochondria. But of course, the modern dietary lifestyle, I think, damages them far more. And I think it's far more insidious than most people recognize because it happens over a lifetime, but it's constant. It's like multiple meals throughout the day, lots of carbs coming at the mitochondria, and they're just not, the way they evolve, they're not set up to handle so many meals with so much sugar coming through all the time. So health and mitochondria need a balance of what we call, forgive my wording here, the big words, but anabolism, which just means building up the body, and catabolism, which means breaking down part of the body. Now, when we are anabolic, we grow. And now that's important for a kid, a child, or perhaps a pregnancy. You want to be more anabolic than catabolic. But an adult, which is most people, certainly almost pretty much anyone with Parkinson's, you need a healthy dose of catabolism to balance out the anabolism. You don't want to be growing because people, when they're adults, grow, outwards rather than upwards. And so the catabolism is really important because it's not just about breaking stuff down, but when stuff's broken down in the body, when the body has a chance to do that, it recycles things. So it can break down old and junky things and recycle those things into new things. And that includes mitochondria. So mitochondria get old and they need to be broken down, and so that new ones can be allowed to come into being. So anabolism is sort of like taking smaller things plus energy to build things that are bigger, whereas catabolism is actually breaking stuff down to produce the smaller units, which can be recycled, and you get energy out of that process as well. Energy is released. So the modern lifestyle that we currently adapt has excessive anabolism because we're eating throughout the day, and it's a lot of carbs. Carbs particularly stimulate this growth anabolism process. The mitochondria aren't designed to deal with this. They haven't evolved to deal with this, I should say. And you basically they get overwhelmed with these waves of glucose spikes in the blood all the time, and it is damaging over a lifetime. It is absolutely damaging. And I won't get into the sort of biochemistry of it, but there's a lot of evidence to show that it is. And they don't have the catabolism. They need time where there's no nutrients coming in. And it's those times, i.e. when one is not eating, that the mitochondria are able to start doing their thing and renewing themselves. And we need our mitochondria to consistently renew, or we have problems. So this whole concept is presented in a paper I wrote last year. It talks about Alzheimer's and cancer and Parkinson's and a lot of disorders, if you want to read more about it. So here's the way I see Parkinson's now, a metabolic view. And I see it as not as a disorder of the substantia nigra in the brainstem. I see it as a disorder of the body, a widespread mitochondrial dysfunction of the body that's particularly bad in the neurons because of the neurons' requirements for high energy and so on. So if you look at Parkinson's as an iceberg, you have the motor symptoms, if you meet someone with Parkinson's, you see the motor symptoms, the tremor, and if you talk to someone who knows about Parkinson's, that the Lewy bodies and substantia nigra are well known by many people. But if you look beneath the surface and you talk to the person more, you might discover there are some problems with sleep, some problems with mood, and all these other non-motor symptoms. And if you talk to someone who studies Parkinson's and push them on it, they'll say, oh yes, there's actually problems with neurons outside the substantia nigra. And beneath that, I think if you really keep going deeper, you're going to see that widespread mitochondrial dysfunction is a really common underlying theme in all of the above. And it can be caused by the gene mutations, pesticides, the herbicides, the head trauma, the multiple daily meals, and the processed carbs. And I put those in yellow because I think they're probably more important than people recognize. So what I'm trying to say is I see all these things as metabolic responses. The body's responding to the problem, and the problem is down here at the bottom. And so we really need to get therapies going here. So for the people with genetic Parkinson's, yes, some gene therapy might be good. Pesticides, herbicides, of course, you want to minimize exposure. Head trauma, minimize exposure. And multiple daily meals and processed carbs, you want to change that dietary pattern to try and eradicate those two risk factors. And I think this is an achievable thing that a person can do. So we're going to focus on these two now for the next 20 minutes. Metabolic therapies. A metabolic therapy is something that just restores mitochondria function. That's really the way I see it. So a well-known classic one is calorie restriction. And that's basically you prolong the reduction in calories that you take in by 20 to 40%. And it definitely has benefits in virtually every organism examined. So I like this monkey example, I guess, because it highlights the power of it. This is from a trial. It's quite old now. So the monkey on the left, the two frames on the left is one, sorry, the monkey on the left of two frames, yes, is one monkey. And the ones on the two frames on the right is another monkey. I can't really see the other monkey because of the Zoom text box. But so if you look at the left monkey and the right monkey, and you think they probably look a little different. The left one looks a little tired, haggard, perhaps quite a bit older. It doesn't have the same luster in its hair. Its skin is a bit saggy. I mean, it just doesn't look as vibrant and healthy as the one on the right. So you might think it's a much older monkey, but in fact, they're this exact same age, these two monkeys. And the only difference is that the left one was allowed to eat as much as it wanted throughout life. It was not force-fed. It was just allowed to eat ad libitum, which means whatever it wants, whenever it wants. The one on the right was calorie restricted. The one on the right gets less cancer and other disorders that affect these animals. So that is very telling testament to the potential power of calorie restriction. Now, other metabolic therapies include fasting regimens and keto diets and exercise protocols. And there are other ones, things that enhance sleep and perhaps work on stress. All of these things damage mitochondria. But I'm going to focus on the first two because the fasting regimens and the keto diet regimens are really the key to improving the modern dietary lifestyle that seems to be correlated with the rapid rise in Parkinson's. So fasting is simply not eating food and drink for a certain period of time. And we use 12 hours as a somewhat arbitrary mark of a fast. So if you fast, if you haven't eaten in more than 12 hours, that's a fast. Now, it can be done different ways. It can be no food, or it can be water only, or it can be water, tea, and coffee. And you can even do other ways that allow little bits of food. So there are different ways to fast. And the key is that what we want to do is get the body starting to rely on its body fat and produce these molecules called ketones. Okay, so ketones are a brain fuel, just like glucose is a brain fuel. Glucose comes from your breads, your pastas, any sugary things. Carbohydrates produce glucose. Any carbohydrate that you eat eventually becomes glucose. The body breaks it down, and that glucose is used up by the brain and the muscles and other parts of the body. But ketones is an alternative, and it comes from fat. Now, when you fast, it's coming from your body fat. So the thing about the ketones is they are superior to the glucose. They actually produce more energy for the amount of oxygen you breathe. They are cleaner. They don't produce as many free radicals. There are other advantages, but they are absolutely loved by neurons and muscle cells, including heart. So ketones are really really prime fuel for your brain and your muscles. And there's different ways to do these fasts. So first of all, I always, when I get someone to do these fasts, I really have to help them understand that this is the natural normal state. And actually the 3 meals a day, the modern dietary lifestyle, that's the abomination. That's not normal. And although everyone thinks it's normal, it is not. Just because everyone thinks something is true, it doesn't make it true. And it's not true. So time-restricted feeding is a good way to start. 16 hours a day, 8 hours of eating. You can go to 18 hours of fasting a day, 6 hours of eating. 23 and 1, that's called 1 meal a day, OMAD. I like that one a lot. That's what I do all the time, pretty much. So you fast for 23 hours and you have 1 hour where you just have a nice big meal. TMAD, I coined that term, I guess. I don't know, maybe someone else uses it, but 2 meals a day. You could do 2 meals a day if you're not ready for OMAD. And then you can do other longer fasts. I wouldn't counsel doing this unless you had some guidance, if you haven't done them before. Anything over 48 hours you can do. You just need to get some water and salt in there. You can't do that without the water and salt for very long. Keto diets are really, I just see them as another metabolic therapy. So I see them more as a method of getting the body into this keto state, getting the ketones up and the glucose down, rather than as a diet. And that's a really powerful way to look at it, because this avoids the whole carnivore versus vegetarian versus vegan versus whatever problem in the diet space. Keto diets can be all those things. So it doesn't matter if it's carnivore or vegetarian. I've had patients on both. So the key with the keto diets is you, again, want to make ketones. And instead of the body fat making the ketones, it's the fat from your diet. So that's basically done very easily, to be honest, by removing sugar, grains, and fruits. Those 3 things. And actually, those 3 things are, I call them processed, somewhat processed foods, all 3 of those. Because if you go back just a few thousand years, which is not very long time in human history, we only had farming in the last few thousand years, and it's the farming that has produced these huge amounts of grains and made fruits very different from their natural state. The original fruits, watermelons, peaches, and bananas, and so on, the wild forms 10,000 years ago are extremely different to what they look like now. The farmers made them bigger and full of sugar for obvious reasons, tastier. And so you just knock those 3 things out in a keto diet, and then you just punch up the natural fats, and that's like your olive oils and so on. So that's really all it is at its core, and it can be done so many different ways. It's adaptable to any person, whether they want to be omnivore, carnivore, vegetarian. It's adaptable to any ethnicity. It's adaptable. The fiber, the fibers, if you have a high carb diet, fiber is important. If you are, say, on a carnivore diet where there's like 0 carbs going in, I do not think it is important. It is not necessary. And there's plenty of evidence to show that. So keto diets, that's just a very quick snapshot of them. But basically, they're kind of like fasting. They're just trying to get the body into this ketogenic state and make it, give the brain some better fuel and help the mitochondria restore themselves. So both the fasts and the keto diet do that. So how do they do that? Well, the power of these things, like a medication levodopa is an excellent medication. I use it in Parkinson's a lot. It's fantastic. But even levodopa can't do anywhere near what these things can. So they induce an orchestra of changes on metabolism throughout the entire body. So first, you increase the ketones. That makes it better fuel for the brain. And if you have any sort of diabetes or type 2 diabetes, well, I've had patients on type 1 do this as well. It really is excellent for those conditions. Also, fasting and keto diets, they induce what we call neurotrophic factors. Like there's a common one called BDNF, brain-derived neurotrophic factor. These are basically growth things for the brain and the neurons. It's a very good thing. So paradoxically, when you're fasting, doing the keto diet, these things go up. And they suppress inflammation, which might be an issue because there is low-grade inflammation in Parkinson's, Alzheimer's, other similar disorders. You induce repair mechanisms. So the mitochondria coordinate the cell, remember? They can actually help start inducing repair. And epigenetic changes is just means, epigenetic just means how the genetic code is read. Whereas genetic means, what the genetic code is. So epigenetic changes, again, probably driven a lot by the mitochondria, you want to get the cell producing so-called good proteins and not the bad proteins. And these fasting keto diet strategies can do this. And lastly, of course, they really do restore the mitochondria. So you are reducing oxidative stress, you're encouraging mitohormesis, which means the mitochondria get more resilient and more efficient with time. Because the truth is, fasting and keto diets, certainly when you start them, are mild stresses, and that is a good thing in the long term, a little harder in the short term. So medications make things easy for you in the short term, but in the long term, you get side effects and stuff, it gets harder. Keto diets, fasting are the opposite. They make things a little harder in the short term, but things in the long term get better. That's why the first few weeks are always the hardest, and that's when a lot of people give up, even if they're getting the right guidance, perhaps. But long term, the more you stick with it, the better it gets. So they also enhance mitogenesis, which is birth of new mitochondria, and mitophagy, which is taking out the old junky ones and recycling them, so you can do mitogenesis. So I hope you can see there just a snapshot of what fasting keto diets can do. And those things, all of those things, those points there can really be beneficial in a complex disorder like Parkinson's. So I guess this trial is quite old now, 5 years. We did a randomized controlled trial to look at a keto diet in Parkinson's here at Waikato. It involved people from the Waikato and Bay of Plenty regions. And we basically just randomized people to keto or a low-fat diet. So we took people and said, okay, you're going to get keto, you're going to get low fat. It was a roll of the dice kind of thing. And we just followed them for 8 weeks. It was not a long trial, but we didn't have much funding. So we wanted to just look at a keto diet versus a low-fat diet, a healthy recommended low-fat diet, like a good one. It didn't have a lot of sugar. It was basically a lot of multi-fiber grains, multi-grains, I should say, and vegetables like potatoes and legumes and things like that. And it was very high in fiber. So it is what a low-fat diet supporter would say, yes, that's a decent diet. And importantly, we matched the diets for protein. That's so important in Parkinson's, because I hope you are all aware that protein really messes the levodopa up. So whenever you if you're taking levodopa, Cinemet, Matapar, and so on, it's so important that you give it an hour before or after any food before you have the levodopa, and you should only take your levodopa with water, because there's, not milk or anything. There's so many things that have protein in them. So you'll get the best bang for your buck if you do that. Now, we looked at non-motor symptoms and motor symptoms using this very, very good scale. And we looked at motor complications. That's the dyskinesias and things like that people can get from the medications. And the study is down there. It was published 5 years ago, of course. So what did we find? Well, we enrolled almost 50 people, and we just measured their glucose and ketones every day for 8 weeks. Now, the ketones are in red, and the glucose is in blue. And so, and then on the bottom of that graph, you have weeks into the diet, and on the vertical, you have basically, it says the BHB level, that's the ketone level. So over the low-fat diet, the low-fat diet's ketones are in blue, not the glucose. The low-fat diet had a very low ketone level throughout. 0.2 millimole per liter is about what someone on the normal Western diet would have, or any non-keto diet really. And the keto diet, they were at about 1.2 for the entire 8 weeks. Now that is actually mild to moderate ketosis. You can get higher, but what that translates to is that the ketones in these people were supplying perhaps 20% of their brains at metabolism and neurons elsewhere. That's potentially significant in Parkinson's, where maybe we just need to, compensate for that sort of 10 to 20% shortfall, and that might help the mitochondria out. So you can get stronger keto diets, and we are using stronger ones for our current trials in advanced cancer patients. And then you can get really, really high ketones if you do the prolonged fast, 3-4 days of fasting, you can get them really high. So what do we find? So if this graph shows down is better, red line is the keto group, blue line is the low-fat group, and so down means better. Now you can see that by 4 weeks, they were similar. The keto group seemed to be a little better, and this is all the non-motor symptoms together. So lumping them all together and adding the scores. And then at week 8, you can see that the keto group really started pulling ahead considerably. In fact, the drop was tremendous, and it was just over 40% improvement from baseline. The low-fat group did improve too by about 10%. Remember, this was not a bad diet. It was it did not have beer, it did not have ice cream, it did not have a lot of these other things, and it had a lot of fiber. So I think this was a very good diet. But clearly the keto diet went a lot better. And this was not just statistically significant, but clinically significant. That means it was obvious clinically, right? There's a lot of things in trials that people do, and they show a statistical change that's significant. But if you have 1,000 people in a trial, just the tiniest little change can give you a statistically significant difference. Whereas, a patient with a trial with 50 people, you need a significant change to get that. So anyways, they were clinically significant changes, and that's quite tremendous for only 8 weeks. So there are the differences there. You can see the actual numbers of improvement. Now, interestingly, the most improved non-motor symptoms were the urine problems, the pain, the fatigue, sleepiness, and cognitive impairment. And that's interesting because these are the symptoms that levodopa doesn't help so much with. So these are some of the most disabling, least levodopa responsive symptoms. And the motor symptoms and complications improved in both groups. So both improved by about 20 to 25%. Again, the low-fat diet was good, I think. I think that there might have been a placebo effect. So when people expect to get better, they actually can get better. That probably played a part. I think both diets were better than the vast majority of what people were taking before the trial. So that probably had a beneficial effect. I guess the keto diet, remember, it's such a massive change in that concept of hormesis I mentioned. So things get a little harder before they get better with the keto diet. So i.e. that first 4 weeks, maybe people had a harder time adapting to it, and then they got more benefit weeks 4 to 8. And I just wonder if we'd gone to week 12, would we have seen more, including motor symptom improvement? Well, I don't know, because we didn't take it out that far. So based on that, I would say what we need now are trials that look at fasting in Parkinson's, because we didn't look at that. And maybe longer term trials that look at fasting and keto diets together potentially. So I guess a nice trial to think about would be something with a metabolic therapy program. So an actual way of not just changing the diet, but changing its appearance or the way you word it into a metabolic therapy program, which could be something like intermittent fasting plus a keto diet against a person's usual diet. Matching the protein would be important, I think. But something like this, you could randomize people to a metabolic therapy program or a usual diet. And then, if you could do it for longer, like sort of 6 months trial, something like that, maybe you could see some powerful improvements potentially. And I think you'd have to take it, knowing what I know now, because I've learned a lot in the last 5 years, I think 6 months would be a reasonable time frame. 8 weeks was kind of short now in retrospect, but again, funding was an issue. So look, if that sounds interesting to you, we're very busy with our cancer trials right now, but in the future, maybe coming back to this would be interesting. And that's our website there that you can contact me through if you had any particular interest in that. I just would want to know how many people might be interested. And it would be involving Waikato and Lakes and Bay of Plenty, obviously, potentially other sites in the country. So to conclude, Parkinson's has been around thousands of years, but it's really increased at a rapid pace and just in the last couple of decades. And I think the most likely culprit, I can't think of anything else that's changed as much as the modern dietary lifestyle. And we know that the modern dietary lifestyle just overwhelms the mitochondria with nutrients, and it prevents them from renewing themselves. And over many years, that's a problem. It damages them. So a deeper metabolic view of Parkinson's perceives it as a disorder of widespread mitochondrial dysfunction, rather than just, focusing on the brainstem, that little substantia nigra. I think we really need to broaden our horizons if we're going to do some serious beneficial work in this disorder. And I think metabolic therapies are promising because they change the entire body. They induce an orchestra, not just an instrument, but an orchestra of changes that really are fundamentally aimed at restoring the mitochondria. And yes, you get improved weight in people who are overweight. And yes, you get improved diabetes in people who have diabetes, pre-diabetes, and so on. But really, it's about restoring the mitochondria, and that is the potential to restore something like Parkinson's. I think I might be wrong. Remember, but I think that's that's a very enticing concept, and I believe true. So keto diets do seem beneficial, but our trial was the only randomized trial. It was the first one. There's been one other, but they looked at slightly different things. They had some improvements. They showed some improvements too. But basically, we need more trials and we need more research in this area. And there are reasons that we haven't got more trials, but we can get into the Q&A if you like. But thank you for watching.
Wow, Matthew. Thank you for a fantastic presentation. Wow, that was very thought-provoking. You've got quite a few questions here to ask you, and
okay.
These folks post a few more questions if you want to. We've got Matthew for about another 20 minutes. So Matthew, if I could start, where do I start with all? Can you just, I mean, you, in my opinion, you're knocking over some of the things that I've been raised on, like your 5 fruit a day. So were you saying fruit is wrong?
Okay. Well, so look, I'm not anti, so it depends. If you, in the current context of where we have a lot of obesity and overweight, most people in New Zealand, for example, are overweight or obese and have probably almost half have pre-diabetes. And these are things from excess sugar, essentially. So in large part, in that sense, fruit is wrong because fruit is essentially sugar. It has fiber. In the skin in particular, but it is essentially sugar. And a lot of people don't realize that. So vegetables are far superior because they have a lot more fiber compared to the digestible carbohydrate. And now if you were on a low-fat diet so a low-fat, high-carb diet, and it's healthy with tons of fiber, like the one we did in the trial, that can be good, and fruits can be good in that. Those people ate a lot of fruit. It's the problem with the standard Western diet is high carbs plus high fat, 50% carb plus 35% fat. The combination is the deadliest. So it's I think second best to go high carb, low fat, but you can best in the current context because people are overweight and so on, so much many metabolic problems. High fat, low carb is the best, and fruit is not part of that. So it's contextual. It's not like fruit is bad or fruit is good. It's what diet are you doing? What are your goals? What are you trying to achieve? For most people with Parkinson's, particularly if you're overweight, fruit is bad.
So one of the questions is, are you talking about eliminating all grains? So the example they give is amaranth, I think I pronounced it correct, and quinoa.
Yeah, good question. So look, I think it's good not to be a purist with these things. You can do, so the cousin of a keto diet is a low carbohydrate diet. And that just means, so keto diet is sort of less than 50 grams of carbohydrate a day. A low carb is less than 100 or even 150. So it allows more carbs. And if you are putting in those, quinoa, high fiber carbs, that you can have that in a low carb diet, but not in a keto diet. I don't let people who we start keto diets on those things. It will mess up the ketosis. So if you want to see an example of low carb versus keto recipes, dietdoctor.com has really 2 sections where they have low carb recipes and keto recipes, and you can just compare them and see the difference. So yes, it's okay for low carb, but not keto. Low carb it has many benefits too.
Right, and FODMAP versus keto?
Well, keto, if you do keto properly, it is essentially pretty good for a FODMAP approach. And another thing, like people get a lot of people get they want a low gluten diet, so because celiac is so common. And again, if you do keto properly, you are automatically getting rid of the gluten. So if you do a keto diet properly, it actually overlaps with a lot of the other diet strategies out there. But the goal of the keto diet, unlike those other diets, is I think it has a deeper goal, and the deeper goal is to directly restore mitochondrial function, which to my mind, it is the best at, because it's not really a diet for that purpose, it's a method.
Right. So the one person's asking, so parties lose weight, it seems to be a general trend. So do we have to be concerned about a sudden weight loss or, a sustained weight loss?
Yeah, fantastic question. So Look, because I think 2/3 of people in the country are overweight or obese, so the body mass index is over 25, weight loss is good. When you do intentional weight loss, it's good. The trouble is being overweight is now the new normal. So when I have people in our trials get to a nice body mass index of 22 or 23, a lot of other people say, oh, you've lost so much weight, are you okay? And the fact is they're doing fantastic, and they're actually in the normal range now. So yes, the weight loss is good. Now, some people with Parkinson's are already in that nice range, and some people are a little underweight, BMI 18, 19. Now, first of all, the weight loss is not as good in those people. I don't like it if people get under a BMI of 20. It's extremely rare. And the reason is when you do the keto diet and even the fasting protocols, your BMI really, it's hard for it to shove under 20. It resets the BMI, the weight to 20 to 25, a nice body weight, and it doesn't tend to go below. And I've got a bunch of patients doing like a whole bunch of 5-day fasts and 1 or 2 meal a day keto diets, a very powerful protocol. And I've seen that in them. There's one guy who started that at the body mass index of about 19, and he has not budged from 19. So you don't get underweight with these things unless you're doing something incorrect. And that's why a bit of guidance can help.
Right. So always get to ask advice. It's good about, especially about body weight.
Yeah, if you're getting weight loss and you're under the body mass index of 20, that's a problem, and something needs to be altered.
I'll just read this question out because it's quite a complicated one. I've been intermittent fasting while on a lower carb diet for 2 years now. How can I tell when enough is enough? Should I be including a 48-hour fast every 2 weeks, for example? How can I objectively monitor my progress?
Wow. So first of all, congratulations for doing this for 2 years. And intermittent fasting can mean different things. So typically fasts that are sort of less than 24 to 48 hours in duration. So the daily fasting is intermittent. It's very hard to be objective with oneself. So that's why it's important. Like in our trial, we had neurologists who didn't know these people at all or what diet they were on doing these half-hour assessments on the motor symptoms. So it's really the best way to be objective. It's hard to tell oneself how one is doing. You could ask friends or family members how you're looking, month by month. They are more objective. But I guess because we don't have very many studies and data and evidence for this, it's a bit of a leap of faith right now, especially at the 2-year mark, as to what to do. So if you wanted to improve the metabolic pressure, because you're very used to a low-carb intermittent fasting approach now, you could try to widen out the fasts a little bit and try to dip into keto diets more and see if you actually want to measure your ketones. You can get a monitor at any pharmacy and see what kind of ketosis you're getting and take it to a new level. That would be one thing you could do. So if you're doing 16 and 8, for example, 16 hours fasting a day, you could go down to a 2 meals a day strategy, no snacks, or even throw in the occasional OMAD 1 meal a day. But yeah, again, we just need so much more evidence for this. And, we need longer term evidence in particular to know if it's actually working.
Well, we've got at least one person here saying they'd love to participate in a 6-month trial. So,
oh, good, good to hear. I'm just gauging interest right now. Yeah.
Maybe we can ask folks to email us and just give us their names as contacts for you for the future. So we've got someone here that says that they weighed 80 kgs at age 65, diagnosed with Parkinson's in 2015, followed a keto diet for 3 months and lost 10 kgs. I was unable to stall the onset of my symptoms of PD medication, was extremely affected and weighed 58 kgs in mid-2021. Had to go on to apomorphine pump late June 2021, and I experienced a significant improvement. I now weigh 73 kgs, participate in many physical and social activities. My question is, can a person with a slim build with a low BMI commit to a serious ketogenic diet, reaching ketosis and potentially losing a significant amount of weight and receive additional benefits? Or is there a flexi variation possible which maintains a reasonable body weight? So, very complicated question.
It is. So the answer is yes. A thin person, I believe, can achieve the benefits and certainly can achieve ketosis and not lose the weight too much. However, that being said, I think anecdotally from our trial, the people who are overweight probably got easier time staying in ketosis because they have more body fat that can help get the ketones up too. And they might have had a little more benefit in the Parkinson's, which is interesting. However, the thing about being thin already is it just means that you have to be a little more careful about the weight loss. But again, like I said before, patients that I get on these protocols who are already thin, they don't really tend to lose the weight if we're doing things properly and making sure that we're doing the fasting and keto diet protocol properly. And again, your experience is absolutely what I would have expected. So again, the medications are going to help right away. Including the apomorphine, fantastic medication. It's just that in the long term, as you know, these things become harder, including the apomorphine. But whereas the keto diet in the first few weeks, could be tough, especially if you're having too much weight loss. I don't know how tall you are, so I don't know if your body mass index went below 20 or not, but could be hard. And however, sticking with it, it gets better in the long term. So the experience you've had is very typical. I hear of people, and I guess I'm not surprised. But yes, thin people can achieve ketosis, and I believe thin people can benefit. Certainly in our trial, thin people did benefit, but just perhaps not as much.
And Matthew, any cultural, is this Caucasian? What about Pacific peoples who carry additional weight? What about people from Asia who are smaller stature? What's the variations there?
Yeah, so I have some Maori patients, couples, for example, who the Maori tradition, the ancestral diets, most of them are very amenable to keto. So the Maori diet, for example, this couple basically does full Maori traditional diet. They just knock out the starchy things, the kumara, for example, and the yams, for example, and they just go with a lot of coconut cream and seafood and things like that. Fantastic for keto. Now, as you get farther away from the equator, traditional diets are more keto. So, for example, the Inuit in northern Canada was a full carnivore keto diet, almost no carbs, whale, seal meat. The Mongol diets, reindeer, almost full carnivore, pretty much. The traditional Scandinavian diets, and so on. So those really northern people, if your background is like that, Northern European, Northern Asian, then perhaps keto makes even more sense. Now, as you get closer to the equator, so Southeast Asia, for example, carbohydrates become more prevalent in the ancestral diets, but there's a whack load of fiber in there too. Now, so they would not be in ketosis as much, but all people throughout the world would have been in ketosis for probably most of the time in our normal evolution, because food was not eaten 3 times a day, and it wasn't just sitting there on a plate ready for us. We had to fast and go without sometimes, frequently probably, and our body would have been in ketosis. So everyone's body is able to do the natural, normal state of human evolution and what our brain and muscles prefer, which is ketosis. And so that's why it's really flipping one's mind to understand that the way modern society is now is not the normal state, and that the normal state we can induce in ourselves just with a bit of discipline and a bit of focus. And why are we doing this? To restore our health, our mitochondrial health. That is so helpful because, and it doesn't matter where people evolved in that sense, but the person who is maybe of a Northern European background might really enjoy a carnivore diet with fasting, whereas a person from the Southeast Asian background might enjoy a vegetarian keto diet or an omnivore keto diet with fasting, and maybe even dipping out of ketosis once in a while with some nice, traditional, not so processed carbohydrate foods from wherever they came from, their ancestors came from at the same time. But being in ketosis most of the time is the beneficial state.
So this person refers to the blue zones, areas of the country where there's a high vegetable seeds eaten and high longevity of people.
Yep. So the blue zones is nice. So there's there's a few blue zones. Remember, the concept of blue zones was based on an article that came out a few decades ago. And, so for example, you've got Sardinia in Italy, you've got Icaria, a Greek island of Icaria, you've got this Nicoya Peninsula down in Costa Rica, Loma Linda, California, and Okinawa, Japan. So look, if you look at the blue zones, first of all, there are multiple factors involved, and people are always trying to figure out what's the cause of this increased longevity in these zones. Most of those zones had intermittent fasting. Okay, so I think intermittent fasting is a big part of that. And the second thing is the blue zones are often in slightly poorer regions of the country, and they actually have a stronger network of family and social structure, and that is an important factor. Okay. Another thing is they probably are having decent exercise, sort of, walking decent distances throughout the day as well. But so there are multiple things to think about with the blue zones. But I would say that the fasting is a very powerful key element that unites most of the blue zones, and they don't overeat in the blue zones, and they might even be calorie restricting a bit too. So they're adopting a metabolic therapies on a number of levels, even though keto diet isn't one of them.
So is there any evidence that Parkinson's incidence is less in the blue zones?
I don't know.
No. So one really good question, and we fast running out of time, unfortunately, is where would you start? So I've never done a keto diet before. Where do I get the information? How do I make a start? What do I do?
I'd start with fasting. So I wouldn't change the diet. I would just introduce intermittent fasting, 16 hours a day, for example, at start is a nice way to start, and then you build it up. If you want to know more, so Diet Doctor really is probably the best site I know of, dietdoctor.com, where they talk about fasting, they talk about low carb diets, they talk about keto diets, and there's lots of nice recipes there. Our website, metabolicneurologist.com, there is a plan there that people can download if you click resources, and it's basically a 2-meal-a-day keto diet if you want to jump in more. I spent a few years making that. So there are different resources. It's very important to make sure you're on a resource that gives you information that doesn't charge you a fee, because anyone charging a fee obviously has ulterior motives. Unfortunately, that's just the way it is. So I would say the dietdoctor.com probably would be the best site, and take it from there. But start with fasting. Unless you want to go hardcore, don't start with the keto diet.
So one person says that the idea of eating all the meat and fat involved in keto puts me off.
Yes, well, that's a common misconception, though. So you can do carnivore keto diet, but you can do vegetarian keto diet. And I've had patients do vegetarian keto diet. There's no meat at all. Now, the fat, remember, most people with Parkinson's are sort of the baby boomer generation, maybe a bit of the silent generation, the one before. But so in that baby boomer generation, fat was demonized, okay, in a very big way, particularly saturated fat. And that's just so difficult to change. That's the psychology of it, because fat, the thing is, it's fat plus carbohydrate that's bad. It's not fat. Fat is very healthy and continues to be demonized and stigmatized based on bad evidence and bad studies, and just basically hearsay and dogma. But if you have the high fat without the carbs, it's very healthy. Okay, that's very healthy, and I think the healthiest dietary option at this point in time. So if you can't change the psychology to see fat as really good, and some people can't, some of my older patients with Parkinson, I remember had Parkinson's in that trial, had a hard time doing that. It will be hard, because what the brain says is its reality is reality. So don't do the diet unless you can change that misconception first.
So I'll just try and wind up a few questions as we draw to a close. So one person asked about a link between, they've heard that medication for epilepsy can be a precursor or a causal factor for Parkinson's. Someone else is saying that their daughter has got a genetic diagnosis, generational. You said it in the presentation, 10% is genetics. So basically, I think the thrust of the question is, does a keto diet have any preventative value? So if we put our children on it, are they going to
Okay.
be better off?
Okay, I'll answer those in succession. And I don't mind staying later if you don't mind, but so you just let me know when you want to end. So medications can induce Parkinsonism. A classic one, like for epilepsy, might be Epilem or valproate. The answer to that is you've got to stop the Epilem or the valproate. I'm not sure if a keto diet fasting protocol would help much. It might, but really you want to get the medication off. The other thing, the genetic Parkinsonism. So I think a keto diet, a metabolic therapy would help those people still, because you would basically, the problem with that is the genetic mutations are resulting in mitochondria damage, but you can help the mitochondria heal up through alternative pathways that are elicited by the fasting and the keto diet. So that's very interesting. And I'm looking at that in something like Huntington's, which we know is basically genetic cause. But the mitochondria can support their the keto diets and fasting protocols can support their mitochondria because they're also damaged in Huntington's through alternative pathways. And I am looking at this in a couple of patients, and it seems to be helping. Now, with kids, I do not think a keto diet is a terrific idea. And again, same in pregnancy. Remember, the keto diet is there to restore mitochondria, particularly when they're already damaged, which is most people. But kids, not so much, and kids need to grow. So this is often a theme at metabolic conferences. What is the best diet for children and pregnancy? Probably low carb, and occasionally, especially for kids, adding in a decent amount of carb, say 2 or 3 times a week. So a nice amount of carbohydrate just to spike the growth, but not all the time, and not carbs as in tons of sugar. Which will, not be good for even kids, but carbs like potatoes and starchy things, and not too much, not as much as you might think. So the body doesn't need much carb. Remember, you can live on fat and protein alone without any carbohydrate whatsoever. Your body can make all the carbohydrate you need. Your body cannot make the protein it needs. It cannot make the fat it needs, okay? It must have those coming in somehow. But carbohydrates is the third of these so-called macronutrients that is not essential for life in any way. So remember that as well. Carbs are not natural. I'm not against carbs, but right now for most people, the best strategy is high fat, moderate protein, low or no carb, because you just don't need it. Your body makes all the carb you need. So, but kids, I think a little bit of carb sometimes would be good.
So one of the questions, can you comment on the milk? So dairy milk or soy milk or?
No milk, no milk. Cream, that wonderful New Zealand cream that is so hard to get in other countries. If you're doing a keto diet, I just put sort of a couple of teaspoons of that in my coffee because I eat 1 meal a day, and then for the coffee, I'll just put a little bit of cream in it or have a black. No milk, because milk has sugar in it. And again, for kids, I think that's fine. Milk, some milk is good, but for adults, especially if you're on a keto diet, no. If you're on a high carb, low fat diet, a good one, then milk would be okay. And in that case, I think you could use any of those options.
And people are asking about like the teas, the fruit tea, your good old gumboot tea or English breakfast.
Tea is great. Yeah, pretty much any tea, as long as you don't load it with sugar. Or milk is good, and same with the coffee. I think coffee. They show the more coffee one drinks, the less chance of getting Parkinson's or Alzheimer's, up to sort of 7 cups a day. It's a powerful correlation. Now that doesn't mean that more coffee causes less Parkinson's. It might, but it probably doesn't. It just means that for some reason there's a reverse correlation, and so it doesn't mean I can start prescribing coffee to people with Parkinson's. But it's one of these things where certainly it doesn't seem to be damaging people with Parkinson's. So if in doubt, have some more coffee, have some more tea.
And you spoke right at the beginning about constipation being a common trouble for parties. So how does keto diet or diet and constipation, what's your advice there?
Super common. Yeah, it's super common. I was worried about that when we did our Parkinson study. I thought, oh my goodness, we're starting this keto diet. it can induce constipation in some children that have tried it, and I hope this doesn't happen, and it didn't happen. So it was extremely rare side effect. I guess the diets, there's different kinds of keto diets. So we used a modified one where it was sort of not like the classic ones made 100 years ago that are very much meat and fat and very hard to sustain, in my opinion. But the newer keto diets, it doesn't seem to be an issue. And even people on the carnivore keto diets, you have fewer bowel motions, but no actual constipation, as in sitting on the toilet straining away for a long time. And it makes sense on a carnivore keto diet, you're going to have fewer bowel motions because you're absorbing more of the food. There's no fiber going through, right? So your fiber is what goes through and gives your stool the bulk. Vegetarian keto, carnivore keto, omnivore keto, Parkinson's, constipation was not a big issue, interestingly.
So someone's asking, saying I've got a BMI of 22. Is that in the range? That's good.
Yeah, perfect range. So 20 to 25 is normal. 22 is perfect. I would say, if that person started a fasting keto diet protocol, they would probably go down to 21, maybe 20. And should not go below 20, though. If you're going below 20, that's too much. And again, if you do other things, you can mitigate this. For example, if you exercise and do weights, strength related exercise, you can maintain your BMI and even increase it while you're doing this. If I'm not careful, on one meal a day, my weight goes up. So, and I don't want it to go up. I'm happy with where it is. But it's 22 is a great place to be. So, that's good.
So a question here, what about these dietary supplements? Anything that you would advise to have?
I'm not a fan of supplements. I'm not against them. I use some, very, very few. So the one I find beneficial is magnesium, particularly for Parkinson's, because it helps people with cramps and it helps with sleep. And sleep is almost universally disrupted. Pretty much anyone with Parkinson's, if they're not on levodopa therapy overnight, are going to have some insomnia, even if they don't know it. So I don't use too many supplements outside of magnesium unless there's a documented deficiency. So vitamin D, for example. It's the trouble with the supplements is at the end of the day, they're like medications. They're little changes. So you're doing a little change here and a little change there. And I'd rather just change the whole body with a fasting or dietary protocol that changes the whole body's metabolism. And another thing about supplements I don't like is that sometimes you have paying quite a bit for them. And we have, as low as the evidence is for the diet sphere, it's even far lower for the supplements. There's no real good evidence that too many supplements are effective in Parkinson's, to my knowledge. So,
lots of people just saying thank you, Matthew, for the presentation. Found it really informative and really useful. A number of people saying they'd like to participate in the trial, and I'm just going to get Lawrence to post up an email address so people can just email and their interest in being part of a trial. So,
okay,
just cruising through the. So this one is, my daughter was diagnosed with fragile X cingulation. And I was diagnosed with Parkinson's in 2015. Should I be tested?
What was the daughter diagnosed with?
Fragile X.
Tremor ataxia syndrome, like FXTAS, maybe?
That detail's not in here, sorry.
Okay, yeah. I've never had anyone with that condition or any fragile X-related condition on these protocols, so I don't know how much it would help there. Sorry.
And I think that's we've got. Now ask this one. I've been intermittent fasting while on a lower carb diet for 2 years now. Oh yes, I did ask that one.
Yeah, we did that one.
Enough is enough. That one. Oh, someone's asking about the cost. Is keto known to be expensive or cost effective?
Oh, yes, it'll cost you a little more because you're starting to. So basically, when you do keto, you'll find you're hitting the outside of the supermarket a lot, not so much the aisles. The processed stuff is in the middle. The stuff in the refrigerated sections is is keto. And remember, a keto is normal food. It's natural, normal food. So you're going to be eating, if you do a typical omnivore one, more meats and more green vegetables and olive oils and things. And most of those things don't have a label. So you don't need a label for them. They're fresh. And that's what you're going to do. But unfortunately, they charge a little more for particularly the meats, the steaks and things like that, and the fish than the processed stuff. The carbohydrates get subsidized a lot so that people can buy them. And this is part of the issue. So it will cost you probably 25% more, or depends how you do it, 25 to 50% more. But if you throw in fasting, so you're eating once or twice a day, that will mitigate the cost of a keto diet. So that's a nice thing. And you can actually get it down to be about the cost of a sort of standard, usual diet. And I've had people in the trials who are on the pension, so not very well to do in terms of finances, and it's more difficult for them, but they can do it. So I guess if you're prioritizing your health as one of your top one or two things, then a little bit of an extra cost might be worth it.
Well, Matthew, thank you so much for a fascinating presentation. Matthew will be presenting again at 7 o'clock tonight, but if you want to register, you have to re-register. You can't use the same link for the 7 p.m. session. It also has been recorded and we've put on our YouTube channel. You will automatically receive a link to that in the next few days. People are also asking if they could have access to your PowerPoint, Matthew. People have really found the information that you presented fascinating and interesting and would like to go back and recap on what you've said. So thank you so much for everything, and thank you everyone for participating. It's great to have you on the chat. Thank you for all the questions. That really does stimulate the conversation. So thank you everyone, kia ora everyone, and thank you Matthew.
Thank you.